Okay, guys, sorry about having to watch another video. I do not know what the deal is with the internet with Google Meet here. Hopefully we will get to the bottom of it. They said they worked all weekend and it was fixed, and it's not. Okay, so what I want to do is I just want to do a few example problems of finding inverses when you have exponents like this. And we don't have a lot of experience with exponents. And the experience that we do have, a lot of it is back from Math 1, so it's been a little while. So let's just start like normal, where we switch x and y. And I got to get this y by itself. Okay, now this 4 is in front of the y. It's not attached to that negative 2/3. So I'm going to get rid of that 4. Okay, so I could write x over 4, or I could write 1/4 x. It means the exact same thing. Okay. Okay, so now what I got to do is I got to get this negative 2/3 off of that y. I want the y all by itself. Okay, so what you're going to do is you're going to raise this to a power that is the reciprocal of this. And we're going to use the same sign because I don't want it to a negative exponent. Okay, so notice the notation that I'm putting parentheses on the whole thing, and then I'm going to do that. And whatever I do to one side of the equals, I have to do to the other. And again, it's very important that you put these parentheses, because if you just put that negative 3/2 on the top, it doesn't imply that it goes with the 4 as well. Okay, so x over 4 to the negative 3/2, I'm just going to leave it like that, is equal, so notice that a power to a power, we multiply. So this is saying negative 2/3 times negative 3/2. These just all reduce down to a positive 1. And we don't need to put that 1 there. Okay, we're going to work in this chapter with simplifying things like this. For right now, I want you guys just to go, okay, the inverse, I'm going to just leave it like that. So x over 4. Okay, so that's how we're going to go ahead and get that. Okay, let's look at another one. If f of x, okay, so notice what I've done here. I've done the exact same problem, but I purposely put in parentheses here because I want you guys to notice the difference between this one and this one, okay? Because those parentheses means that this negative 2/3, not only does it belong to the x, it also belongs to the 4. In this case, it only belonged to the x. Okay, so I'm going to start by switching my x and y. Oops, I'll just go ahead and switch it from this step. I'm going to go x equals 4y. Okay, so this time I can't divide out that 4 like I could up here because it's attached to that negative 2/3. So I'm going to go ahead, and sometimes we use brackets when we have parentheses. It just helps us to see what we're doing a little bit better. Some people just use parentheses within parentheses. It's kind of a personal style. Doesn't matter. Okay, so now I have x to the negative 3/2. Remember those, a power to a power, I multiply, and they're reciprocals of each other, so it'll just equal 1. Now I can divide by the 4. Okay, so we've got that x to the negative 3/2 over 4 is equal to y. And then if I want to write that using inverse notation, x negative 3/2 over 4. Okay, so really important that you look at the difference between problem number 1 and problem number 2. Okay, and then kind of my goal today is really just to give you guys a little bit of practice with every type that you might see. Okay, now when you see a negative 8 x over 5. Remember that that is the same exact thing as negative 8/5 x. Okay, it's just a preference in style, but sometimes people get stuck in one style and they forget that these are the same. Okay, so let's go ahead and switch our x and y. And then I just need to multiply by the reciprocal to get that off of there. Okay. Whatever I do to one side, got to do to the other. So negative 5/8 x. I could have written negative 5x over 8 if I wanted to. And I can use inverse notation. And let's go ahead and let's just write it that way because it's just so much fun. Okay, so that one's just kind of like a regular old linear equation that you guys would have been fine with. Okay, let's look at some ones that have some radicals in them. Like, what do we do with those? So let me get a new piece of paper here because it's going to take up a little bit of space. Okay, so instead of calling things square roots, we call them radicals because we're going to work with cube roots, fourth roots, fifth roots, all sorts of roots. So let's say that we had this and we wanted to find the inverse. Okay, so you want to remember that a square root is the same thing as the 1/2 power. Okay, so let's go ahead and switch our x and y. And then I'm going to rewrite it like that. Okay, notice that there's no parentheses because the 1/2 only goes to the y. It did not go to the 4. So now I would divide both sides by 4 so that x over 4 is y to the 1/2. And then to get rid of that 1/2, I'm going to square it. And you could think about that I'm going 2 over 1 because I'm just multiplying by its reciprocal. 1/2 of 2 is 1. And I could rewrite this as x squared over 16 because I just squared the top and squared the bottom. And I don't really need the 1 there. So I'm going to use inverse notation. And there it is. So anytime you see a square root, you want to change that to a 1/2 power. Okay, what if we had a cube root? Let's add something like that. Okay, so again, I want you to notice the difference between these two. See how on that one, the 4 is on the outside of the radical? This one, the 4 is on the inside of the radical. Okay, so when I write this one, I'm going to keep the whole thing in parentheses. And when you see a cube root, that just means to the 1/3 power. Okay, if it was a fourth root, it'd be to the 1/4. A fifth root, be to the 1/5. Okay, so that's a little number in there. It's called our index. Okay, so let's go ahead, let's switch. Okay, now in order to get the reciprocal of 1/3, that would be cubed, or 3. I could say 3 over 1 if I want. Okay, I'm going to put a little bracket here, and I'm going to say I'm going to cube that, and I'm going to cube that. Okay, so then I get the x cubed. Okay, those are going to cancel each other out, and it's just going to leave me with 4y. Now I can divide by the 4. I could not divide by the 4 up here because of that 1/3. So x cubed over 4. And then I'm going to use my notation. And it's going to look like that. Okay, let me see if there's we'll skip the domain type for right now because we don't want to listen to a big old long video if we don't have to. Okay. Oops, I should have f of x equals. Okay, so let's see what we have here. We have y equals, so I'm going to rewrite this as x to the 1/3 plus 4 over 5. Okay, now, I saw a lot of interesting work last week with these that people weren't really sure what they were doing because I don't think they watched the video. Okay, so first thing, let's switch our x and y. Okay, so here's where I saw people just kind of get some random stuff. All we're doing is we're multiplying everything by 5. Okay, so you could think about it like I'm cross multiplying. 5 times x equals 1 times that. You could think about it as we're using fraction busters, but it's like I'm taking everything and I'm multiplying it by 5. Okay, that gives me 5x, and then here the 5 would cancel. Okay, oops. Now, I've still got to get this y all by itself, so I'm going to subtract 4. And then I have to cube both sides to get rid of that. Okay, so notice I got to keep this whole thing. I could use parentheses. I don't know why I picked brackets here. Okay, so I got to cube both sides. So this is going to stay like this, 5x minus 4 cubed. Be careful, you can't cube the 5x and you can't cube the 4. This is a binomial cubed. We'd have to write 5x minus 4, 5x minus 4, 5x minus 4. Okay, so I have that. 5x minus 4, and I can't separate them. Okay, I have to just write it like that. Okay, the only other thing that we're going to do today is that you guys are going to work, you're going to graph some inverses, and you're going to do that on Delta Math. And when you graph inverses, what I want you to do is just go point by point. Okay, so let's say that you had a graph that looked like this, and they gave you some points here, or that you could see the points. Okay, look for those lattice points where you can see what the coordinates are. Okay, so what I want you to do is you're going to go, all right, x and y. So this one's at 0, 0, and this would be given to you. It's not going to be given to you like this. Like you'll have to look on the graph. This one is going to be at 2, 4, and this one's going to be at 3, 9. So what you want to do when you graph the inverse is just switch those. Okay, so switch them so that it goes 0, 0, 1, 1, 4, 2, 9, 3. And in Delta Math, they're going to give you like a little graph, and they're going to actually let you plot points this time. Okay, so that you would go, okay, 0, 0, 1, 1, 4, 2, and then you would have a graph of the inverse. Okay, so remember, any graph that they give you, just look for points that you can find. They're called lattice points, the ones that, you know, cross nicely. Make a little table, or even in your head, just flip those x and y's and you'll be able to get the graph. Okay, hopefully that's good enough.